Welcome to Chapter 1, Lesson 1.2. This is going to be on basic functions and graphs. Again, a lot of this is going to be a review from Algebra 2. Bear with me. Hopefully it's not too boring, and we get through it. We'll start getting to some harder stuff soon. But all right, let's go. All right, so the objectives. We're going to find the domain and range of a relation, determine whether a relation is a function, determine whether an equation represents a function, evaluate a function, graph functions by plotting points, use the vertical line test to identify functions, obtain information about a function from its graph, identify the domain and range of a function from its graph, and identify intercepts from a function's graph. Sounds like a lot. It is a lot because that was probably a full chapter in Algebra 2, but we're going to condense it into one lesson. Again, this is a lot of review. All right, definition of a relation. A relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain of the relation, and the set of all second components is called the range of the relation. In other words, the domain is the x, the range is the y. All right, so if you take a set of ordered pairs, find the domain and range. Notice how the x coordinate of every point in the relation is the values in the domain. And similarly for the range, the y values in every point given in the relation are the y values that end up being the values of the range, right? So again, remember, domain is x, range is y. Definition of a function. A function is a correspondence from a first set, called the domain, to a second set, called the range, such that each element in the domain corresponds to exactly one element in the range. So for every x, it is paired with exactly one y. If it's paired with more than one y, that makes it not a function. So determine whether a relation is a function. All right, so here's your ordered pairs, 1, 2, 3, 4, 6, 5, 8, 5. Is that a function? Since no two ordered pairs in the given relation have the same first component and different second components, the relation is a function. Even though there are two y values, it's okay that they repeat. It's if there was x values that repeated and were attached to different y values that it would make it not a function. So this is good. This is a function. Functions as equations. If an equation is solved for y and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x. So similarly, if one x value gives you more than one y, it doesn't work. It's not a function. So for this one, determine whether the function defines y as a function of x. X squared plus y squared equals 1 is your function. If you're determining whether an equation is a function or not, solve for y. So the first thing you would do is just subtract x squared to both sides. That's what's happening in the first step. And if you have y squared and you're solving for y, you're going to take a square root of both sides. And you end up with y equals plus or minus square root of 1 minus x squared. The fact that when you take the square root and the square root of something is plus or minus, for instance, right, the square root of 4 is plus or minus 2. Well, the square root of 1 minus x squared is plus or minus the square root of 1 minus x squared. The fact that it's plus or minus implies or indicates that there are two values for y. So that means it's not a function. All right, function notation. The special notation f of x, and you read that f of x or f at x. I never say f at x. I would say f of x, but I guess it's both. Represents the value of the function at the number x. That's interchangeable with y. So sometimes, well, the difference would be an equation would be y equals 3x plus 2. In function notation, it would be f of x equals 3x plus 2. So it's just notation that makes it different. All right, evaluating a function. So let's say you have f of x is equal to x squared minus 2x plus 7, and it's asking you to evaluate for f of negative 5. What that means is substitute negative 5 for x, okay? So as you can see down here, f of negative 5 is the same function that was given with negative 5 substituted in for both spots where there's an x, and then you just simplify. So negative 5 squared is 25. Negative 2 times negative 5 is positive 10. And then the plus 7 remains plus 7. Add it all up, you get 42. So f of negative 5 equals 42. Proper function notation means you're going to present the answer as f of negative 5 equals 42. You're not going to just say the answer is 42. All right, so if you're doing a problem in function notation, answer it in function notation. Graphs of functions. The graph of a function is the graph of its ordered pairs. All right, so we're going to graph the functions f of x equals 2x and g of x equals 2x minus 3 in the same rectangular coordinate system. So select integers for x, starting with negative 2 and ending with 2. So we're going to do that on a table. All right, so I have them filled out. Again, if you're following along, you can either just be watching, or if you're following along with the note sheet, you can fill it out. So the values for x were given. All right, so they didn't come out of thin air. You were directed to pick negative 2, negative 1, 0, 1, and 2. You get the y values by simply substituting negative 2 in for x. 2 times negative 2 is negative 4, and that's your ordered pair. You do the same thing for negative 1, 0, and all the way down. For the g of x function, negative 2 is substituted in for x. 2 times negative 2 is negative 4, minus 3 is negative 7. And again, it's the same process for negative 1, 0, and all the way down. When we plot the points for f of x, that's in red. That would be the line there. And then g of x is in blue. Okay. Vertical line test for functions. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So all the different things we're talking about, whether something is a function or not, it's for a given x, is there more than one y? A vertical line test is testing the same thing. It says use the vertical line test to identify graphs in which y is a function of x. If I draw a vertical line anywhere on this graph, you're not going to touch it more than once. So this one is a function. On the contrary, if I draw a vertical line on this one, I will touch it more than once. So it's not a function. This one, if I draw vertical lines anywhere, I will not touch it more than once. So it is a function. For a circle, if I draw a vertical line, I will touch it more than once. So it is not a function. Analyzing the graph of a function, use the graph to find f of 5. Again, if you're being asked to find f of 5, 5 is the x value. We're going to figure out what's the y value. So if 5 is the x value, I find out where is the function where x is 5. So it's right there, right? So I'm looking at 400. So f of 5 equals 400 by analyzing the graph. For what value of x is f of x equal to 100? So essentially that's saying the y value is 100, what's the x value? So if I do essentially the same thing, but all right, so y value is 100 right about here. So if I just travel around Let's say it's right about there. All right, so f of 9 is equal to, well, they're saying 125, somewhere around there. I mean, and let me be perfectly clear, a question like this where you're looking at a graph and just um, trying to make a determination like that. I mean, it's not an exact thing, so you're in the ballpark. If you gave me an answer that's 1,000, that's obviously wrong. But 100, 125, something like that, you're good. Okay. Um, so that's analyzing a graph. Identifying domain and range from a function's graph. To find the domain of a function from its graph, look for all the inputs on the x-axis that correspond to points on the graph. So again, if you're being asked for domain, it's all the x. To find the range of a function from its graph, look for all the outputs on the y-axis that correspond to points on the graph. So if you're being asked to find the range, it's all the y. Use the graph of the function to identify its domain and range. So again, its domain is all the x values. So I'm just looking at this from left to right. What part of the graph is covered from left to right by that blue function? So on the left, it's -2. It's continuous all the way to that point, which is +1. So the domain, depending on which notation you're using, the x is between -2 and 1. That would be set notation. -2, x is between -2 and 1. Okay. For range, we're looking at the y, so I'm only viewing this from top to bottom, or essentially bottom to top. The lowest value, the lowest y value, is down here, and it's 0. It's continuous all the way up to here, which is a y value of 3. So the range is all the values of y between 0 and 3. And again, two different types of notation there that mean the same thing. Same question, different graph. All right, so I'm talking about the domain. Again, it's horizontal, so it's left and right. On the left, I've got -2. It is continuous all the way to that point there on the right, which is 1. The only difference here is that it's an open circle at -2, which is why in the first notation, it's just less than, it's not less than or equal to, because -2 is not included on that graph, so -2 is not included in the domain. Everything to the right of -2 is included, so that's why it's -2 less than x less than or equal to 1. With the set notation, it's parentheses around the -2 instead of a bracket. Okay. For range, the lowest y value is -1, and it travels up to 2. So -1 is less than or equal to y, because it's a closed circle there, is less than 2, and it's less than because it's an open circle at 2. And then it goes bracket -1, comma 2, parentheses. Again, two different notations that mean the same thing. Identifying intercepts from a function's graph. Find the x-intercepts. Look for the points at which the graph crosses the x-axis. To find the y-intercept, look for the point at which the graph crosses the y-axis. A function can have more than one x-intercept, but at most one y-intercept. It can't have more than one y-intercept because then it would fail a vertical line test. It would have more than one y for one x. So identify the x and y intercepts of this graph. Again, the x-intercepts are where it crosses the x-axis. So in this case, it's -3, -1, and 2. Its y-intercept is -6, the blue point. All right, and that concludes the notes for lesson 1.2. Um, so I'm assuming you're either watching this Thursday after you finish the lesson quiz or over the weekend. Um, like I said in class, we will, I expect you to view the notes before class on Monday, and we'll start the practice for this lesson in class together on Monday. That way I'll be there for questions. Have a great weekend, and I will see you then.